let's go through equal 1658. Minimum operation to reduce x to 0. For this question, it gave us integer array nums and integer x. It said that every time we can either select one of the number from the left or from the right, and use the x subtract this number and ask what's the minimal time we get this x to be 0. If we cannot get x exactly to be 0, then we'll return -1. So for this question, if we try to simulate from the left and the right, it will be kind of complicated. So we want to see the minimal times we select from the left and plus the right, right? And of course we can. So if we can think about to do some transactions, is that if we can find a longest subarray, that is kind of we're looking for the shortest two part, right? Shortest two part, which is summing up to this x. That the question is transferred to if we can find a longest subarray, which is sum to sum minus x, right? Sum is the total number of this array. Then the times will be n minus the longest, right? So if we know this transition, it is just trying to let us to find the longest subarray, which each equals to a target, right? So that is a very easy question. For these nums, we're trying to find the longest subarray, which is the sum to target. So there are two approaches. And for this question, it said that the nums are all positive, right? So if without this question, we can use a map, right? And have the fixed sum and try to check the map if there is some kind of number they have current prefix sum. If there exists current prefix sum minus target, right? And that is for there is positive and negative number in this nums. And for this one, as it is positive, right? So we can just use 2 pointers actually. Because use prefix sum, we have ON space complexity, right? Time complexity, they are the same, that is ON. But use prefix sum, use a map, we have extra space. So for map, because that is all of them are positive, right? So we can use 2 pointers. That is, we have left pointer, right pointer, right? And keeping moving the right pointer. If it acts more than the target, right? Then we move the user while loop to move the left pointer, and jumping out of the while loop, if the sum equals to target, then we get a local sum, right? So for every right, we have a local sum. We compare with a global sum, global longest, right? After we get the longest, then we have n minus longest, that is shortest. So let's write code for this. Let's get total sum, right? Into for this range, the sum will not 10 to the power 9, right? So it should be fine. We'll have sum equals 0, and n equals nums upper length. So we'll say for int num in nums, let's say have sum plus equal to num, right? So our target is into target. We are looking for the longest subarray, which is sum to target. Target is sum minus x, right? So let's have a longest int. Longest equals integer dot mean value, right? So what we do is that let's have int left equal to 0, right equal to 0, right? For right smaller than n, right plus plus, and every time we move the right, we let's have a window sum, right? Window sum, okay, equals to 0. Every time we move the right, we have a window sum plus equal to nums right. And let's say while this sum greater than target, then we'll move the left pointer, right? Left pointer plus plus. Before this, we need to have window sum minus equal to nums on left. So when we jumping this out of the while loop, let's say if window sum equals target, we have the result will compare longest equals max dot max longest in the right minus left plus 1, right? So in the end, if the longest is still integer dot mean value, means we didn't find subarray target equals target, right? So return longest equals -150 is integer dot mean value. If this integer dot mean value, then we return -1. Otherwise, we return longest. It's n minus longest. Our result will be n minus longest, right? So this will be the Java code. Minus left. If this is greater than target, that equals to 0. For this kind of case, we have true, auto true. That is because our sum equals 1, right? And our target is -1, right? So we are keeping moving the left and the left. So let's write this left smaller equal to right at this condition, right? Okay, so this is the Java code. Let's change this to Python. So we'll have total equals in Python there is a sum function, right? Nums, and we'll have target equals what? Equals sum total minus x. So we're going to have let's have n left right wing sum, okay, because length nums, and at the beginning left point is 0, right point is 0, and also window sign is 0, right? So we'll say while we'll say for for right in in range range n, right? Range n. So we'll have win sum plus equals nums, right? And I will say while left smaller equal to right? Don't forget this condition for this case. If we don't have this, just have a moment ago we have 1, 1, 3, right? So because the target is -1, no matter how we move the left, it cannot reach the -1. Then left will move out of range, right? So while left is smaller equal to right, and win sum greater than target, target. Then we'll have left have win sum minus equal to nums left, and left plus equal to 1, right? And jumping out of this while loop, we'll say if win sum equals target, right? So in this case, we're trying to see our longest. Do we have a longest variable? We should have a longest, right? Longest. In Python, longest is minus. How can we? In picture. In infinity, whatever. Python. Okay, let's do this. Float minus IF, okay. And the longest will be max, right? Max longest in the right minus left plus 1, right? In the end, we're trying to see if longest is still didn't update, right? Return -1 if longest equals float minus IF, else will be n minus longest. So this is a Python code.